Continuing with 1.9, we are on 1.9b, inverse functions. The key word here being functions. So let's think about inverse functions on whether or not this particular function will have an actual inverse. The key to it is that yes, it may have an inverse, but will the inverse be an actual function itself? So if you're given an inverse and it is not a function, it is that particular function does not have an inverse. So let's think about a regular function. Let's think of a line, right? A flat line. Let's say y equals 2. This in itself is a function. And if we were to draw the dotted line of the y equals x, the inverse of it, wouldn't it just be the perpendicular equivalent from the dotted line? Here, this would be the inverse of it. However, that inverse does not pass the function test. It is a vertical up and down line, so it is not itself a function. So the inverse does not exist here. It does not exist because the inverse itself is not a function, even though we were originally given a function. Same things can go with, let's say, curvy lines. Some curvy lines, parabolas definitely have an inverse after if x is greater than 0. However, so let's say if we were given like a cosine graph, and it kind of looks like a wavy like this, right? And if we were to draw the line down the middle, the inverse of that would be kind of like be a wavy line down this way. And as much as we like to, this doesn't have an inverse because it doesn't pass our vertical line test. So we cannot say this has an inverse. So this in itself is also does not exist. So let's think about inverses now. How can we check if whatever we are given algebraically, if it does have an inverse? If whether or not the inverse of that works. Well, the only way we can really do that algebraically is we have to think about whether or not it will have more than one answer in as an x. If it has more than one x value that is the same, then it cannot be in inverse. So just like that line, right? Y equals 2. Well, our x equals 2. All of the next one is x's 2's. That definitely cannot happen. Not an it does not exist. What about, let's think about something that, try something a little bit more difficult. Let's say, what about 3 over x squared? Well, to find our inverse, we just have to then switch our y's and our x's to find it. So 3 over y squared equals x. Here, then we are left with what y squared equals 3 over x. And then the answer then is y must then equal the square root of 3 over x, or plus or minus the square root of 3 over x. Since this is a plus or minus scenario, what if we had x equals 1, right? If x equals 1, and we plug that back into our equation, then our y could equal positive root 3 or negative root 3. So that means there is a coordinate of 1 comma root 3 and a 1 comma negative root 3. So there are two x's with two different values of y's. So this is another does not exist value. The only way we can do this is to solve for it algebraically and to analyze and think of it algebraically.